Hello and welcome back. In this section, we'll dive deeper into iptable's targets. A target is the action that is triggered when a packet meets the matching criteria of a rule. There are two types of targets: terminating targets and non-terminating targets. Terminating targets perform an action which terminates the evaluation within the chain. The packet matched by the rule will not continue traversing the current chain or any other ones in the same table. Depending on the target, the packet might be dropped or accepted. Drop is such a terminating target. For example, if the matching criteria of a rule drop the packet is dropped and no other rule will be evaluated. On the other hand, a non-terminating target performs an action and then the evaluation within the chain continues. The packet continues traversing the rules in the chain. Each chain must eventually pass back a final termination decision, but any number of non-terminating targets can be executed before that. Log is such a non-terminating target. For example, if the matching criteria of a rule log a packet, the packet is logged and then the next rule within the chain will evaluate the packet. Let me show you a first example of a terminating target. In a new shell script, I'll write two iptable's rules. The first rule will accept incoming SSH traffic and the second will drop any TCP traffic. Both accept and drop are terminating targets. I'm writing the rule that accepts SSH traffic. iptables -a input -p TCP -d port 22 -j accept. And the rule that drops all other kind of TCP traffic. iptables -a input -p TCP -j drop. Let's think for a minute what will happen. When an SSH packet arrives, the Linux kernel will accept it and the packet will not be evaluated against the second rule. That's because accept is a terminating target. The second rule will evaluate only TCP packets other than SSH and drop those packets. It doesn't matter if there are other rules that are accepting the packets. Drop is a terminating target, the packet is dropped and will not continue traversing the chain. Let's test it. I'm saving the script, then make it executable and run it. Let's try to connect to Linux 1 using SSH from Linux 2. And we notice that SSH is working. That's because the first rule has accepted the packets and the second one hasn't evaluated them anymore. If I list the firewall, I will see matched packets by the first rule. There are 12 matched packets. And no packet matched by the second rule. Notice that the second rule hasn't matched any packets. Now let's try to connect to Linux 1 using a browser. There's a web server running on Linux 1. In the address bar, I'll write the IP address of Linux 1. And the page is not loading. If I list the firewall again, I'll see that the packets are dropped by the second rule. There are 8 dropped packets. Let's move on and see a second example with a non-terminating target. I want to log and then drop incoming SSH packets. In the same script, I'll log incoming SSH packets. So instead of accept, I will use the log target. This rule will log incoming SSH packets. And the second rule with the same matches will drop SSH traffic. I'm saving the script and running it. From Linux 2, I'll connect using SSH to Linux 1. We notice that SSH is not working. The packets were dropped by the second rule, not by the first one. The first rule has logged information about the packet headers, and then the packet continued traversing the chain and were dropped by the next rule. iptables -vnl. I am listing the firewall. We notice that both rules have matched packets, and it's the same number. 6 packets have been logged and then dropped. The log target uses the kernel log facility. If we execute the message, like this, we'll see the logged packets. These are the headers of a logged packet. That's another proof that the packets have been logged and only then dropped.